Alright, in this video we're going to work practice problems 10 through 17. We'll start out with number 10. And we have, of course, this great formula, future value equals present value times 1 plus r to the t. And we want to solve for r. Okay, this is something you've done in high school algebra but probably forgotten. So I divide both sides by present value. Future value divided by present value is equal to 1 plus r to the t. What I need to do now is raise both sides to the 1 over t. Something you may remember from high school algebra, the base to any exponent, if you take that entire thing and raise it to 1 over that exponent, it's equal to just the base, or the base to the first power, because you multiply those exponents. So if I take both sides and raise to the 1 over t, like this, then I have future value divided by present value raised to the 1 over t is equal to 1 plus r. And now just rearrange. R is equal to future value divided by present value raised to the 1 over t minus 1. Yes, the calculator will do this for you, but right now I want you to practice with the algebra. It's important to get realizing exactly what's going on with the equations. That in-depth knowledge of the equation is what's going to separate you between somebody who really knows what they're doing and somebody that's just punching numbers. You don't want to just be a number puncher. You want to actually know how to do this stuff. So now we're just drawing the equations again. The timelines again. And we'll start here with number 11. You were willing to pay no more than $3,000 today. So we have today. I'm going to put a negative 3,000 because you're going to pay that. And then over here, in year 3, you're going to receive 3,600. And I'm going to put that positive. Just in any transaction, at some point you're paying money. If I'm paying money, somebody else is receiving, and at some point I'm receiving and they're paying. So I'm just choosing one to be negative, one to be positive. That's just so I can see what's going on. But if I'm going to do this like the equation says, r is equal to the future value, 3,600, divided by 3,000, and I don't have a negative in there because I just wanted to see here, this is just to indicate where the cash flow is going, and this will be important with your calculator later on. And that's raised to the 1 over 3 power minus 1, so that's equal to 1.2, and you could raise this to the 0.33, 1/3 is, just put a bunch of 3's in your calculator, minus 1, and that's equal to 0.1253. There are more decimals. I rounded that off, and that's the same thing as 12.53%. Okay, number 12 is going to be very similar. Repetition's the key here. We just keep practicing. And number 12, you deposit $4,000 today. So I'm just going to make that again negative so I can see that I'm paying money. And in 5 years, it's going to be $6,000, where the interest rate is going to be equal to the future value, 6,000, divided by the present value, 4,000, raised to the 1/5 minus 1. That's equal to 1.5 raised to the 0.2 power minus 1, which is equal to 8.45%. I'll skip the decimal form and put it right in percentage form there. And let's go to question number 13. 13 says an investor would be indifferent between receiving $20,000 today. So I'm receiving either $20,000 today, so that's positive, or $40,000 in year 13. So that's why I started using the plus minus on the timeline. It's just, I want you to be cognizant of, is cash going out or coming in. Here we have the choice between money coming to you. The interest rate is going to be equal to, I'm just going to do 40 over 20, right? 40,000 over 20,000 is the same thing as 40 over 20, or 4 over 2 for that matter, raised to the 1 over 13. I have no idea what that is off the top of my head. Subtract 1. Crunch through the math on that one, and you wind up with 5.48%. And then let's go to question number 14, and here we're going to be solving for time. So let me clear this off. Question number 14, we start with future value equals present value times 1 plus r to the t, and I want to solve for t. That's going to be tough. So future value divided by present value is equal to 1 plus r to the t, and you have to think way back to your high school algebra classes and remember natural log. If you don't, that's fine. Natural log of future value divided by present value, take the natural log of both sides, and what happens is that t comes out of the exponent and the natural log of 1 plus r. So if I solve for t, it's equal to the natural log of future value divided by present value divided by the natural log of 1 plus r. So I mean, you may be thinking, well, I don't remember any of that from high school math. That's fine. There's a button on your calculator that says ln, and for your purposes, it's kind of magical. And I'll show you how we can use this. I'll leave this answer up here, and we'll go to 15, and of course we'll draw a timeline. And it says in number 15, you deposit $2,000 today. So today I deposit $2,000, and I like to think of depositing as negative, and it's going to earn 10%. The interest rate is going to be 10%, and it's going to grow to be worth $3,200. But I don't know when. I don't know how many little dashes are from 0 to there. So what I do is t is equal to the natural log of 3,200 divided by 2,000. Don't worry about the negative. Over the natural log of 1.10. You solve that, and t is equal to 4.93. So 4.93, I'm going to write out years. It'll take 4.93 years for $2,000 to become $3,200 in an account that earns 10%. So what you do in your calculator is now you do 3,200 divided by 2,000 equals natural log. You have that number, and then 1.1 natural log. You have that number. It's going to be important that you get used to your calculator, that you can make sure you and your calculator are communicating, and it's giving you the answer that you want. So whichever calculator you're using, make sure you learn how to do that stuff. Alright, suppose you deposit $6,000 in an account today. So there's $6,000, and it's going to earn 7%. So the interest rate is 7%, and I don't know this year. That's what I'm looking for. And it's going to be worth $9,800. So same drill. Time is equal to the natural log of 9,800, the future value, divided by 6,000, the present value, over the natural log of 1.07, and that is equal to 41.28 years. And let's just put 17 right here. So number 17, I deposit $50,000 today. So here's today. I'm going to put 50 instead of 50,000, and I'm going to have an interest rate of 5%. And I don't know how many years, and I'll get 100,000. I'll just put 100 instead of 50, because all it's doing is just doubling. So the time is the natural log of 100 divided by 50, which is the natural log of 2, divided by the natural log of 1.05, and that is equal to 14.21 years. Okay, so that's finding interest rate and finding time.